Okay. Hi guys, good evening. Please confirm that you can hear me. Okay. Okay. So, um, no problem. Thank you. So, I want to apologize again for yesterday. You know that there was a lot of things did not really go as planned yesterday, and that's fine. So, we the embedded systems as software because I realized that I'm saying this again because the recording of yesterday, I don't know. Um, I'm handing over the embedded systems class to Afolabi because I realized that trying to handle the administrative part of YFE, planning for events, and then handling most of the things in the back end is just very demanding. So I said that in an attempt to grow and actually learn delegation and be more intentional about delegation and preservation of start doing things more effectively in a way that is not going to affect me health wise and every other thing. That it's better that I just learn to delegate when I can. So for that reason, Afolabi is going to be the one to be taking the embedded systems class from now on. And I know that yesterday didn't really go as planned. And again, we want to apologize for that. But we hope that today is going to be better. So, Afolabi, you have the floor. And he also told me that he prepared a material for you guys that you'll be using moving forward. So, yeah, Afolabi, you can take over from here. Welcome.
Okay, good evening, everybody. I'm really sorry for yesterday. Uh, didn't really understand that most of you didn't really get what I was trying to explain without the aid of diagram. So I got in some diagrams, and today we'll be doing some practicals on Tinkercad. So we'll just be doing like practicalizing what we learned yesterday and practicing it on Tinkercad. Also dealing with some other things like PWA, if and else statements, loops, and other things like that. So, but first of all, uh, let me okay, let me okay, just for share this first. So you can all see my screen, right? So this right here is the wavelength I spoke about yesterday. So you can see from this part, which is the idle state, which is the I volts. When there's a pull on the spring, we know, give example of the spring. When there's a pull, then wait at least 80 milliseconds before for the start signal to get sent from the MC, which is the microcontroller. Then move again, then wait another 80 microseconds, then move again another 80 microseconds before it sends the first byte. That's sorry, the first binary from the 40 bits. So it goes like that for 26 to 28, then goes again for 50 microseconds and like that to 17 and the others. So this is the way it moves from the explanation I had yesterday. So that's by the way. I just wanted to make sure I show you guys what I was actually explaining yesterday. So, but right now we're going to be building an example circuit together. So, and I'm going to be doing that on Tinkercad. Let me get that set up. All right. So I want to make sure you guys can see my screen, right? Can I get any response, please?
Yes, 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 we can say it.
Okay. So uh one
Mhm.
thing that I would like you to all to know is that on Tinkercad, the DHT11 is not available. So we'll be using something else. So we'll be building using a sensor, right? So what we'll be using is we're going to be using two sensors today. We're going to be using a TMP36 temperature sensor. That is uh, this. We're going to be using an HCSR04 ultrasonic sensor. That's this, right? So then we'll also be using an LED and a resistor. So those are the things we'll be using. And before we dive into a building, let me explain how the sensors works. So because yesterday we just made mention of the DHT11. So the HCSR04 is ultrasonic sensor. So what it means is a kind of sensor that emits high frequency radio waves and use it to detect motion in front, motion or distance. Most times it's distance. Some other ones, some other variation detect motion and other things like that. So what happens when this sensor get activated is that when Arduino triggers the sensor, it emits 8 pulses of 40 kilohertz sound. So the reason why it uses 40 kilohertz is because that is higher than the human hearing range. So you normally cannot hear anything above kilohertz. So and the sensor emits these pulses to the left eye. That's if this see. So it emits it from this first one right here, from this left eye. Then that's the transmitter. Then the sensor will bounce forward. Then this uh, this uh this sound waves, this sound pulses that it's like pushes out, travels about 343 meters per second. So the waves spread out at a 45-degree cone. To, I'm going to show you the way it spreads out when we are doing our practical. Well, spread out, sorry, not 45, 15-degree, a 15-degree cone, and it bounces off to the
Abi,
next.
sorry, it's like your microphone is covered a bit, so we can't really hear you well.
Okay, is it better now?
I think so.
Okay.
I think so.
Okay. So what I said earlier was that the waves spread out at a 15-degree cone. So when we are doing the practical, because I don't think it's going to show right here. I'm going to
Sorry,
show
it's
you the way
still
the
low.
looks like. Okay, come on, let me check it out real quick. So is it better now?
Yes, yes, it's better.
Okay.
Okay.
So because I can't really show the 15-degree cone until I run a simulation, I'm going to show you again, but just so that the waves that this left eye that my mouse is on is usually spread out at a 15-degree cone. So then it bounces off the nearest object, might be your hand or whatever object that is just in front of the cone. Then it's now returned or received by this second eye, which is the right one. So that is the receiver. This is the transmitter. This is the receiver. So now what this sensor actually measures by sending out those signals is time. So it measures how long it takes for the sound to make a round trip. Okay, sound that is going from transmitter to bouncing off an object to going back the receiver. So it measures how long it takes. So since we all know the speed of sound, So it uses that to calculate the distance. Formula uses is distance is equals to speed of sound multiplied by time divided by 2. So that's the formula it uses. So now, if we look at the pins, oh, this is the wrong, sorry, this is the wrong sensor, but it's almost the same. Let me get. um, okay, yeah. So okay. So if we look at the sensor, you see that it has 4 pins. So we have the VCC, which is power. So this goes into the 5 volt connector pin on your Arduino. There we have the trigger. So this is the input to the sensor from the Arduino. So this, when you send a 10 microsecond I pulse here, you're telling the sensor to start measuring now. So we have the echo, that's the output from the sensor to the Arduino. Then we have the ground pin. So that completes the electrical circuit. So that's just basic, that's basic configuration for HC SRO4 ultrasonic sensor. Then for our other friend, which is the temperature sensor, that's what we are going to use since we don't have the DHT 11 right here. So this is a temperature sensor, the same way we explained the same temperature, the way temperature is measured yesterday is also the same way it uses to measure temperature. So this time this, unlike the ultrasonic sensor, which is a digital sensor. This is an analog sensor, so this goes to the analog part of the pin. So what we usually do, because Arduino cannot really read analog voltage directly, we use ADC. It's analog to digital converter. So the Arduino has a 10-bit ADC. So I'm going to show you how that works. And the same way the pin works, we have the power, which is connected to the 5 volts. We have the V out, that's the voltage out. That's one that goes to the analog pin. And we have the ground, that's to complete the circuit. So now another one we'll be using, as I said before, it's going to be an LED. So we'll be using an LED, and LED has 2 sides. We all know what an LED is, but LED has 2 sides. This is a cathode and anode. So the cathode is going to be connected directly to a pin. That's so maybe it's going to be a PWM pin, which is pulse width modulation. Modulation. So it's going to be connected to one of those digital PWM pins. While this other anode side is going to be connected to a transistor, sorry, to a resistor. And the reason why it's connecting to a resistor is LEDs are current-driven devices. So, and they have extremely low internal resistance, like essentially 0. So if you connect an LED from a 5 volt pin to the ground, what happens is the I, which is Ohm's law, that's V divided by R. So if the R is nearly 0, I is going to be equals to 5 volt divided by 0.000 ohms, which is going to be equals to 5,000 megaamps, which is is it megaamps? I'll call it milliamps. So which is going to be equals to 5 amps. So, and the Arduino pin can only safely provide 40 milliamps maximum, which means you're trying to draw 125 times the amount. Means that your Arduino pin is going to be damaged and your LED is going to burn out. So that's why you must always use a resistor to connect to an LED, no matter what. That's like a critical rule that you must always remember. So now we're going to restart our circuits today, and we'll start with our Arduino. So let me get this. So I'm sure you guys already know how an Arduino works. So I don't really need to explain too much of it. So same as yesterday, If I'm talking too fast or you don't understand, feel free to ask questions or take me back so that I'm going to re-explain again. So uh, then we're going to get breadboard. Get that here. So I like this around here, then this. Sorry, just taking the board and putting it around here. So now, what we will be doing, first of all, is connecting our temperature sensor. So, what I like doing most of the times is I like okay, any of the tools I'm going to need. I like putting them on the breadboard and arranging them. So I'm going to arrange my wiring. So it's going to make my work cleaner. So temperature sensor, take this thing, put it around here. So take a temperature sensor, then our ultrasonic, get that. Okay, get this and just put it around, let's see, put it around here. Then our LED, put our LED around here. Then our resistor is going to be around here. Okay, so now first things first, when we've gotten all of this, we have to connect the lines, which are the wires, individually. So I like starting with the temperature sensor because that's one of the easiest to start with. Chris. So what you do is take the power pin from the temperature sensor and connect it to the 5 volt on the Arduino. So move like this, like this. Okay. Okay. Around here. Done. Okay. So since you've connected the power, come on. So since these are live, what I like doing is color coding each of the wires. So you take this and change it to red. So you can leave it, but for better understanding, I like color coding my wires. So it's going to be easy to know what each does. Then our ground, take our ground and connect it to the ground on the Arduino, which is right here beside the 5 volts coming. Okay, so change this to black because that's the standard color for ground. Then voltage out, which is our analog, we'll take that and connect it to A0. That's our analog pin 0. So and you have to remember where you connected it to because that's one of the things you have to look at when you're coding it. This is this. Okay, then change this to green. So we've done the first step of connecting your temperature sensor. So the power pin is connecting to the 5 volts, 5 volt. Then the ground is connecting to ground, and the voltage out, which is going to be our output, is connecting to the analog. Since the temperature sensor is analog, uses analog connection. So for the next one, connect the HCSR04, sorry. So same thing, you connect the power pin to power. So a bit tricky. Just like to get everything nice and clean. Yeah. Okay, then change it to red. So then, sorry about that. Now, next one we have to connect is our ground. Our ground is going to a second ground on our Arduino. Good. Just come here. On ground. Then change the color. So black. Now, since the HCSR ultrasonic sensor is a digital sensor, there's a difference in the way it's going to be connected to it's going to be connected. So we're going to be connecting it through the digital PWM pins. So what you do is the trigger, take that, connect it to any of the pins of your choice. So go with pin number 12. Then I'll color code this to yellow, so it's going to be easy to identify. This also, so this just take it and connect to 13. So also arrange this. Then we're going to have, since this is connected, we have to connect the last one on the list, which is the LED. So the way you connect the LED is you connect this, the cathode, you connect it to a ground. So then you now connect this to, let's connect the anode to the resistor. Make sure it's connected very well. Okay. So then what we want to do next is connect the anode. Okay. So we'll be connecting that. Sorry, someone called me. I'm trying to text the person. Okay, so for the second pin of our LED, we're going to connect it to ground. So this is the cathode. Take this, connect it this way. Yeah. To ground, then always you change it to black. Then for the second one, we connect it to a digital pin. So we're going to use okay, which one should we use? Okay, we're going to use 9. So take this. Okay. Okay. Okay, then we change this from black to yellow. Let's separate this. Okay. So does anybody have any questions so far? Or you don't understand the way everything is connected? Let me know so I can cover it. Any questions? Please, I'm waiting for a response. I want to know if there are any questions or not. So, okay, in the absence of any question, we're going to continue work. Okay. So, now, since we have all of this connected, we can't just test it because there isn't any code. So, what we want to do is code all of this so that we can get our logic working. So, we change this to code, continue, then, okay. So, we have this. So, delete this one. So, first of all, I want to explain some things. So, some of the concepts that we're going to be using in our code that I was to explain to you guys is the concept of if statement, else statement, if else statement, else statement, for loop, while loop, and a PWM. Okay, so first of all, we're going to be looking at what if statement is. So an if statement is the simplest control structure. So the if statement does only one thing. It checks a condition, and if the condition is true, it executes execute the code, block of code written in it, and if it's false, it does nothing. So, and the way you write if statements is if, then open the brackets. So let's say we're trying to check distance now, just say distance is greater, so it's less than 10. And so our normal curly braces. So when you do that, so what happens is if this condition that is set inside this block is true, whatever we put here is what is going to get executed. So for example, we can say if it's true, we can just say serial. That's serial is for, so serial is for our serial monitor. That's what we're going to be using to check our output. So serial dot print I can say in get very close. So now, what this code does is, if an Arduino sees this, or if the Arduino sees this block of code, what it does is it's going to read the distance. It's going to say, okay, is the distance less than 10? Is it equals to 10, or is it greater than 10? So let's say the distance is 8, for example, now, and Arduino reads it, checks it, and say, oh, it's less than 10. It's going to go with a yes. Now, when it goes on with a yes, it's going to execute the other block of code that are inside this part, this block of code. So what that does and what this does is it just prints the alert that, oh yes, the object is very close. So then let's say the distance is let's say 25 now. Distance is 25 centimeters instead of 10, instead of less than 10. It checks if the distance is less than 10, and if it's not less than 10, which 25, it's not less than 10, just does not skips the code because there isn't something to we ask it to do after. So now, where this is now different is where we add if else. Now, what if else does is, okay, we know that if the distance is less than 10, we want it to do this. But what if the distance is not less than 10? You don't just want the code to stop. We want it to do something else. So that's where if else come in. So what it basically means is we are adding else to a statement. You know what else means in English. So what you do is in here, just put a space and just add else. Then our normal block. So you don't need to add the conditionals because this condition has already been checked in the first place. This was just giving what to do if this is not correct. So what I'm going to do is same thing. So serial print line. Sorry, let's see. Print line. So okay. The objects. Let's do that alerts. Objects is not close. So it means that okay, if the distance is, let's say, greater than 10, it's not less than 10, it's what is inside the else block that is going to get executed, as instead of just skipping as it did for when it was only if, it's going to execute what is in the else block. So we also have another condition now called else if. So in modern programming, we call it a leaf, but for old C++ that Arduino uses, is if. So unlike traditional else, what this does is sometimes you might be trying to check, okay, if, let me give you a proper example of exam score now. So for example, now you're writing a code that takes the student's exam and checks if it's greater than something to give the score. Let's say 90 is going to be very good, 80 is going to be good, 60 is going to be average, and this and that and this. You can't. So if you were to do it that way, because of it is not just a true or false. There are several categories to what the answer is going to be. So we have to create an else if block. That's sometimes. Okay. So, all right. Okay. Okay. So sometimes it's not just a true or false that you're looking for. You're looking at selections in multiple categories. So for example, now using this example, so what we do is you take this block of code, this very much block of code, put kind of space between it. So take this very much block of code, space, 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 space. Then the closing parenthesis should be forgotten. Okay, so you start with writing the if statement, and this time you have to put your conditional because you are checking for multiple categories. You're not only checking for this, you're checking for another category. We can say, okay, as if distance, let's say distance is less than 20. Less than 20. Oh, sorry, this distance is 20. Same parenthesis block. Always it's okay. So do your normal serial prints. No. Parentheses. Let's do like last the objects is closer than normal. Then you can add another else if as a proper human being would. Else if then same thing with conditionals distance is this is less than 50. 50. Then do the normal thing that we do. Okay. So you say, okay, this one is 20, full space is this, then Thomas Syria, experience line, with this, so objects is its distance. And for this, our else, let's say, so this distance. Okay. So just keep the consistency. Okay, now, so as you can see here, there's because we are checking for multiple categories, which is if the distance is less than 20 but greater than 10, or if the distance is less than 50 but greater than 20, we are using the else if instance. So now, what is critical to know is that conditions are checked from top to bottom. That means starts with this, then goes to this, then goes to this, then goes to this. So starts with distance greater than 10, then goes to this, then goes to this, then before coming here. So it means that whatever you have to do, you have to look at your arrangements very much properly to see if you're actually getting it. So let's say now, if the distance is less than 10, let's say if the distance is 15, for example, now, so it checks, is 15 greater than less than 10? No, it skips that, goes to 20 right here. Then it checks, okay, is distance less than 20? If it's less than 20, in our case, it's yes, because it's 15. We print this, the object is closer than it takes. That means it's going to execute this block and stop. That means it's not going to check the remainder of the conditions. So we call in program in embedded systems program, we call it short circuit evaluation. So that's check. Once you find a match, you stop. You are done. So now, one thing to know that most people that I know that make at first is, for example, now instead of them to start with 10, the same way we started, they can start with a 50 and go to a 20 and other things like that. So that's too broad. So if he is 50, so let's say the distance is 15, because 15 is less than 20, it's not going to like check properly. It's always going to input yes, because the 20 that you're putting at the back after the 50 is still lower than the 50. So it's always going to return yes in the block. So you can never reach the other condition, which is going to be the second one. Now, another uh another problem condition that I like to touch on is called for loop. So what a for loop is, a for loop is a counter repetition. Okay. Sometimes you need to repeat your code a certain amount of times. So, and that's what for loops do. Instead of you to rewrite the code several amount of times, a for loop is there to just loop through the code at a certain number of times. So think of it like doing press up or push-ups. So I'm going to do exactly 10 push-ups. So before you start that you do 10, not more, not less. So a for loop is designed so that your code is going to do the exact number of steps. There's exact number of repetition that you want it to do. So, and the way you write a for loop is like this. Delete all of this, like this. So right, for loop, declare a for loop with a for, then you always start with this complex piece of code. Int int I. That's for every iteration of I, it's going to be equals of 1. Then put a semicolon. So if I is less than or equals to 5, so less than 5. So for less than or equals to, do the normal uh the this. So this, yes, this, but let's do it less than. So let's say if I is less than 5, that's if it's less than, okay, 5, 5, we want the code to always add. So this I plus plus means it's going to be adding one, so it'll be adding one. So now this is the this is the all I like this is the statement. So always declare for loop. So you can say okay, less than 5, less than 6, less than so I mean before it reaches 5, you must always add 1. So meaning that you must get to 5. So since it's starting at 1, that's I is equals to 1. Since it's starting at 1, since 1 is less than 5, it's going to add 1. That's 2. 2 is less than 5, it's going to add another 1. 3 is less than 5, it's going to add another 1. 4, 4 is less than 5, it's going to add another 1. So since 5 is not less than 5, that's when it's going to stop. So now, let's say we now want it to do something. So when you want to add condition to whatever the statement is, let's say you want it to execute a block of code with this statement, what you do is do this. So the normal curly braces, then it starts with our, it's not the, this is our, call it our tabs. That's puts in our white space. So, let's say, okay, digital, digital, right, left, right, yes, and the must always be on the same line. That's delay. 100. This wants to deliver 100. So continue the column, tab, then into the right. So, and comma, go. And this is under the semicolon, then put a mark delay by 100. So, yeah, and with the closing parenthesis. Okay, now let me explain the code. So, a for loop has three parts in its header. The initialization. So the initialization, that's the int I is equals to 1. That's making sure that I is equals to 1. So some people put their I as something else, but default is always 1. So this creates a counter variable. So this run once before the loop starts, and it also sets the starting variable. And there's a condition. So this I is less than 5, that means I is less than 10. So this is what is checked before each iteration. So if true, the loop runs, and if false, the loop exits. So then the increment, that's I plus plus. So it runs after each. What happens is this runs after each increment. So usually to increase the counter. So I means add 1 to I. So I plus plus means add 1 to I. So let's say, for example, now I is starting from 1, as I explained before. Iteration 1, it checks if I is less than 5. If yes, it turns LED on. That's I, then waits, then turn LED off, wait again. So if I is equals to is less than 2, if it adds 1 and it's less than 2, turns LED on, you wait again, turn LED off, then it does that, it does that, it does that, it does that. So now when it now reaches 5, since 5 is not less than 5, it does nothing, just exceeds the loop and continues with the rest of the program. Do you understand that? Any questions? Okay, no questions. So now that's for loops. So while loops are different from for loops in that they are condition-based repetition. So with for, you know how many times you want to loop before you start. That means okay, you want to loop 10 times, you want to loop only 5 times, you want to loop only 6 times, or other things like that. But with while, you loop until a condition becomes false. That means you might not know when that will happen. So for example, now let's say you're boiling water now, and you want to keep eating while the temperature is below 100 degrees Celsius. That means okay, we want to keep the heating of the kettle, that's kettle, the control that keeps the kettle heating, that controls the heat sink for your kettle. You want to keep it on as long as the temperature of the water inside the kettle is not up to 100 degrees Celsius. So you don't know if it's going to take 5 minutes for it to reach 100 degrees Celsius. You don't know if it's going to take 3 minutes. You don't know if it's going to take 2 minutes. But just depends on how the cold water started. So stick check. And the way you write it is fundamentally also different from the way you write a for loop. So a while loop also starts with the declaration as while. So and we put our condition here. So say, well, let's use our boiling water. So say the C is greater than 35. Okay. Let's just use this 35. 35. And this again space in our normal curly braces, then put the enter. So now start with our normal tab space, then I'll like copy that code. Well, okay, digital rights. Yeah, yes. LED P. So LED P, comma, I. I'm going to just looking to that for basis, comma, delete actually, delete, good, and yeah, for basis, and yes, digital rights. Uh, rights, rights, all the service. So, stick to this, more for this is, yeah, so that's going to be delay. For the basis. So, but instead of it to end there, you continue because you wanted to do something. So, what we wanted to do is wanted to we check temperature. So, it's going to be repeat reading. Repeat for us to analog rate. We check the temperatures and so on. As we will get not get result from the temperature P. Temperature P. And for this is voltage region of voltage of your region applied by 5.0. That will be divided by divided by 1024. The number size of the bytes, the number of this is would go to C, so that it equals to in parentheses maybe voltage minus 0.5. That's okay, multiplied by 100 on the again on with our code basis. So that's a bit cool. So now let me explain what this code does. So now what the code is, it's going to check is the temperature higher than 35 degrees. So if yes, execute the loop body that executes the on then checks delays for 2 seconds. It's going to switch on then delay for 20 seconds and rest like that. So it keeps reading the temperature after each iteration, after turning on and off the LED. So if until it finds the temperature what do you call it, less than 35. Well, if it keeps finding the temperature higher than 35, it's going to be looking through this entire block of code. So if the temperature is no longer higher than 35, it's going to exit the loop and it's going to continue the program. It's going to continue executing the other part of the code outside the loop. Now, one thing you should always know is that while using while loops, you have the potential of creating something called the infinite loop trap. So what that means is if your condition never becomes false, that means the loop will keep running forever, forcing your program to hang. So let's say if temperature is higher than 0, because the temperature will always be higher than 0, always going to cause the LED to always on and off without continue executing the rest of the code. So because only if your water gets very cold, yes, and if you get my point, before I start using minus, but you get what I'm trying to say, right? Okay. So now, what a PWM is, since we've done with what PWM is. A PWM is pulse width modulation. So it's for creating analog from digital. So for Arduino pins, Arduino pins are usually digital, and that means they can only be 5 volts on or fully off 0 volts. But if we want to dim an LED, like want to change the brightness of an LED, we need voltage between 2.5 for our brightness, 1.5 for semi-on LED, and other things like that. So what do? We use rapid switching. So PWM doesn't actually create 2.5 volts, contrary to popular belief. Instead, it rapidly switches between 0 and 5 volts so fast that the LED appears to be at a medium brightness because our eyes cannot see the flicker. So, like, when someone is playing with the light switch and they're switching it on and off very fast, but faster than your eyes can blink. And that's about, I don't know, I think 300 or so frames per second. So, flipping it faster than that, you can't really see the flicker. It might be less than that, but I've really forgotten how fast I can capture things. So, but you get the point. So it's flicking between. So, like when you're switching on light switch, you're flipping it off, on and off, on and off, on and off. So if it's on 50% of the time and off 50% of the time, it looks like it is outright. So that's the same way it works. So, and the way is there's a way we calculate it. And calculate it is the percentage of time signal. Sorry, no, the percentage of time the signal is high. So we call it duty cycle, and that's going to be time on over total time multiplied by 100%. Do you understand? Or should we explain again? Okay. So, for example, now, for a 0% duty cycle, means that the LED is always off, and that's a 0 volt average, and that means the LED is dark. With 25% duty cycle, that means the LED is on 25% of the time and off 25% of the time. This is going to be a 1.25 volt on average. That means the LED is going to be dim. So, and if the LED is on 50% of the time and off 50% of the time, that's going to be 2.5 volts average. And then the LED is going to be on a medium brightness or medium brightness. So with the 75% duty cycle and the 100% duty cycle. So, and in Arduino, the way we do that, let me delete all this. The way we do that is use analog write. So analog write, then normal parentheses, then LED pin, specify LED pin. Then for 0% duty cycle, we change to fully to 0. For 25%, that's a dim, change it to 64, because it's from a range of 0 to 255. So for 50%, that's 127. Then for 75%, that's 191. And for 100%, that's full. That's 255. Do you understand that? So now, you might be wondering why are we using 255 and not 100? That's because Arduino uses a 8-bit PWM, and 2 multiplied by 8 is 256. So that's, sorry, it's 255, not 255. So that means that our values are between 0 and 255. So, and the frequency that the Arduino's PWM runs is at about 490 to 980 hertz. So that means that the signal switches on and off about 500 to 1,000 times per second. So this way is faster than your eye can detect. So you can't see changes faster than about 50 hertz. So the LED light appears to be at a steady brightness level. So if you understand what I mean. So this is 7 p.m. already. And I would like us to work on our HCSR04 and what we've built. So this is going to take time to actually write the code by hand. So I've written it down because that's what I plan to teach. So I've written it down. What I'm going to do is I'm going to explain it. So I'm going to explain the code. So now, what's that going to happen is I'm going to copy it and paste it down. Okay, so I will put comments so that's going to be easy to explain because I already guessed that we might not have time. So now we all know how to write C++, right? If there's anyone that does not know how to write C++, can you signify by this putting thumbs up? Anyone?
Sorry, I didn't get the question.
Say, you know how to write C++ code. If you don't know how to write C++ code, just signify by raising up your hand. Or since we have Matthew, okay. So because of Matthew, we have to explain in extreme detail. So now let's start. A constant, is a variable that won't change throughout the duration of your program. So you set constant because okay, you know that the sun, sorry, the sky. No, let me do that. You know that okay, you know that pi is always going to be equals to 22/7. I think yes, 22/7. So you put that as a constant because you know no matter what happens in your entire code, that's not going to change. So that's will never change throughout the duration of the code. It means that no matter what you write right here, it's not going to change what is inside this variable. Then you specify the data type of the variable. That's int for integer. So what we are going to be doing is we're going to be setting a temperature pin. You know, a temperature pin that's right here is in analog 0. So set that. Then for our trigger pin, for that's where the pin that we put our trigger in our what do you call it? And our sensor, our ultrasonic sensor. That's put a trigger pin on that's highest. That's the highest. So so put that on 12. Then echo pin is on 13. So if you look at the code and says on 13, then our LED pin is on 9. So that's the PWM pin for the LED. So now what I want to do is define main block of code as startup, setup. So sometimes it can be main, sometimes it can be setup, whatever you want to put it at. So do a serial.begin. That's since we are not like we're not using a display or anything like that. We're using a serial output. That's why we're using serial today. So we are using a serial monitor to monitor our output. So we have to get that set up. Then the pin mode, that's three pin output, echo pin input, and LED pin output. So you set out what kind of mode they are actually. Then want it to print this. That's control sort of demo. Then for our first loop, so what we want to do is we want this to read the ultrasonic distance. That's what it to read the distance. So switch it off, wait for 2 seconds, switch it on, wait for 10 seconds before switching it off. So now this log is a data type. So because the numbers, like the result of those samples, is going to be in form of integer. So it's going to be in form of numbers. The numbers are going to be very large. That's why we're using the long genotype. So that's a pulsate echo pin I. So that's the result when it's I. Then the float, know what a float is? That's the data type that has the decimal point at the back. We calculate the distance. That's the duration multiplied by 0.034 divided by 2. Then the temperature reading, do the integer, that's for the data type, create a variable called reading, that inside the reading, read the analog from temperature pin as this pin, that's analog 0. Then for voltage, you read from voltage equals reading multiplied by 4.0. degrees for. That's the real temperature. Then this is if statement that is only going to be read if our condition is true. That's if the distance is less than 10, or if statement is going to print as alert object is very close. Then if else, so it's going to choose between two options. That's okay. If the temperature is higher than 30 degrees, it's going to say hot. If it's lower than 30 degrees, it's going to say cool. Then else if, that's else if. So that's what I talked about. So now we're checking multiple conditions in under. So you say if distance is less than 10, say danger zone. If distance is less than 50, you say warning. If distance is less than, sorry, if less than 20, you say warning. If it's less than 50, you say safe. Then if it's greater than 50, it's clear. Then for a for loop, so what we want it to do is, we want the LED, if the distance is less than 15, we want the LED to flash 5 times. That's our code. Flash 5 times, wait for delay, the cycle input flash, flash, flash for each time it flashes. And for the while loop, if the temperature is higher than 35 degrees, so it's going to trigger an LED. It's going to trigger the LED to switch on and off, switch on and off. So we say, I need to print while loop active, and temperature is green alarm. So we check the temperature. Let's go right. That's the condition that checks if something is supposed to happen. And for our PWM, which is our pulse modulator, so we want to take our analog output, we want to get analog output from a digital pin, for example, which is the LED brightness based on distance. What we do is we map the distance, which is 0 to 50 centimeters, I want to use to the LED brightness, which is between 255 to 0. So that means the closer an object, the brighter the LED. So we know that a brightness is going to be like on a number, right? So we create a map. So a map is the number of points that the LED is going to be working with. So we have 0, we have 50, we have 255, we have 0 again. So then brightness is equals to constraint of brightness, which is 0 and 255. That's a constraint of the valid range can be 0 to 255. Then take an analog right, the LED pin and brightness, which is our variable brightness, and it prints PWM brightness is whatever brightness is, then it prints divided by 25, the distance and other things like that. Then last but not least, now display the current readings. Display what distance. What distance is, the display temperature, what temperature is, and other things like that. Then the weight. So let me choose this. Oh, let's just put it this way. So now, for example, now let's see. Okay, our temperature. Let's say temperature is. This our temperature is lower. It's not saying it's saying cool, right? If I put the temperature to higher than degree, say temperature is too high, and you see when I explained about the infinite loop trap, you see because let's say this is a default setting that is always the temperature is always set at this. The system is going to get caught up in a while loop. It's going to be a number ending while loop. That means the rest of the system is not going to, the rest of the code, the rest of the program is not going to run because the while loop is still running. So let's set this back to cool. Then distance. So, what I said about the, so what I said about the what do you call it? The sensor, see, is in a 15-degree cone shape. So you can see that's the distance that the transmitter spreads out the sound waves. So check, you can see it's reading the distance. Then when it comes less than 50, sorry, less than see danger zone, and you can see, I don't know if you can see, that the LED is flashing. I don't know if you can see it. Can you see it? So you can see here that the LED is flashing. So that's to show you that each of our connections are working. So as you can see the calculations for this. So you can see our PWM brightness is being calculated at each distance. Okay, so when it was close, flash that 210, that's creating that flashing, that's dimming and other things like that. So as you can see, that's basically it for sensors, for loops and else loops and PWM. So any questions, please? Diamond, yes, you can. Well, I want to ask you a question.
Sorry, good evening.
Yeah,
Um,
really.
you mentioned something about the long, that is the data type, that because the
Yes.
value is large, that's why we use it. So there was a time I came across something, I think unsigned or something like that, and I was told that it's because the data is large, that's why we're also using that. So when do you know when to use unsigned and long?
Okay. So that's a very nice question. Uh, for the long data type, most times we use it when uh, our data type is mostly integers, a long row of numbers. So unsigned can be mixed. It can be mixed between integer and other types of numbers per se, maybe float and other things like that. So, but the long is mostly used when we are dealing with integers, like very large number of integers. Another thing is that in C++, everything, yeah, you have to assign memory. You have to do memory management manually. Not really manually per se, like assembly, but you have to do it manually. So you have to know when to use each one because the memory allocation for long is different from unsigned. So I won't really focus on that because of the way embedded system is. But if for people that are building critical architecture or critical software, because for long now it can take up to 2 billion numbers. So because it uses a 32-bit int, while for unsigned now, so that takes non-negative constraints. That's when you're dealing with the indices and other things like that. It lets you manipulate your bitwise. I don't know if you know what bitwise is. That's bit manipulation. So, like, let's say you want to manage your bits, including signed bits, uniformly, and other things like that. Also, you can also let you add two data types. So you can do unsigned long. That means you can add the 32 bits of the unsigned and the 32 bits of the long to get extraordinary long, and you can use an unsigned long. So I don't know if that answers your question. All right. Any other question? Yes. Any question? So in the absence of any question, does that mean I can throw my question out in the wind and someone will answer it? Okay. So one question I would like to ask to see if we will put what we are saying. Why did you connect your LED to a resistor? Can anybody answer? Anybody? Since that nobody wants to answer, should I put cash price? Okay, so Israel has answered. Yeah, that's yes, that's correct. So because the LED draws more power than the Arduino pins can take. The 5-volt Arduino pin is going to burn out. So not really the 5-volt Arduino pin. It's the pin that your LED is going to be connected to. That's one of those digital pins. So it's going to burn out. Yes, the resistor reduces the voltage that reaches the LED. So also to prevent your LED from burning out and another thing like that. That's really nice. So I created a material. So it's one of the few ones we drop. So it's 30 pages. Please remain alone vex. So I just wanted to make sure that something I'm going to basically very carefully explain here was I know some of them are deep, but just take. I will also create more depending on the topics on the area. So, but this one really focuses on sensors in general, the other parts calculations that I know they explain here, and some code parts, and also the statement, problem statement that here is the loops and other things like that. So they are very much detailed in the material and other things like that. So imagine if people don't understand that, please forgive me. That it's 30 pages. I just added foundation. So you need to be searching or asking AI to summarize or explain another additional concept to you. So thank you all for joining our class, and I'm very sorry for yesterday's class. So I wanted to make sure I explained the theory before I explained the practice, before we jump into the practical, so it's going to be easier to understand. But I forgot about that. Some people are actually visual learners and other things like that. So I'm very, very truly sorry. Next time we'll do it together, do the theory as we are doing the practical together. So since that's going to be easier to understand. Thank you for joining, and also thank our boss, CEO Princess, for giving me the opportunity to speak to you guys. Have a very nice evening and good night.
Thank you so much for having us, Afolabi. Thank you guys for thank you guys for joining. We'll continue again on Saturday. Yeah, same 6 p.m. So please, I feel like most of us are finishing our exams this week. So nobody has excuse again. Nobody has excuse again. I know Saturday is Valentine's Day. Maybe I will consider, I don't know. Diamond, when are you finishing your exam? The Lord is your strength. Anyway, thank you for showing up regardless, because some people were using Kini as an excuse to not attend classes. But thank you for your commitment, though. God bless you, and don't worry. As you've taken time, taking effort, everything, God will grant you favor and you throughout your exams. In Jesus' name, amen. So I feel like most of us are finishing our exams this week. So please, if you know any of your friends, family members that is meant to be here and they are not here, please, after this week, grace period have finished. Drag them, let them come. If they not come, tell them that they will enter soup. And I already sent notice to the group that if you miss 3 times, if you miss three times after this month, I'm even saying, oh, this month, so that it's not be like I'm a wicked person. This month, after this month, if you people, if anybody misses class 3 times in a row, you like Otilo, like he's gone, like you people will say bye-bye. So sure. Thank you guys for joining. I'll do my best to upload the video to the YouTube channel so that if you want to go back and watch the replay. Network was breaking when Diamond asked a question and when Afolabi was asking, but God help us. MTN and Airtel. I don't even know what to say, but it is well. as well. But thank you guys for joining. Thank you for attending today's class. See you again on Saturday. Maybe Saturday's class will be for 1 hour because of maybe you want to treat yourself out. Me, I have ice cream dates with my friend. We'll sit down and we'll watch movie together. So I don't know what you people's plans are for that day, but those are my own plans. We'll sit down and we'll be enjoying ourselves, licking ice cream and watching movie. So anyway, have a good night's rest. All the best in your exams. Take care. Any questions, concerns, anything, please feel free to reach out and send them on the group chat. Good night, everybody. Afolabi, thank you again. Thank you very much. Obviously.
Please, so I want to say something before we leave.
Okay.
So please, everybody, you see that when I was designing my own circuits, the wires were very clean. Please, when you're doing your own, please try not to make it messy so you'll be able to understand it in the long run. So that's one thing I forgot to mention. Please and please try your best to make it very clean and arranged. So just forgot to mention that. Thank you.
Sure. We've not even given anybody assignments. Since we started this whole thing, we've not been giving assignments. But don't worry, let the exam period pass. We'll start giving assignments. Okay. Good night, everybody. Have a good night's rest. Have a blessed week. Favor is yours. Take care. Bye. You guys can leave the call now. Afolabi, please, what was the question that Diamond asked? Because network was breaking at that part. Oh, so I'll cut this part out. Bye, guys. Stop the recording.